Welcome to Soil Sessions, a webinar series by the Soil Health Partnership, and thank you very much for joining us. I'm Amanda Solman, Communications Manager with SHP, and I am really glad that you all are here today. Please help me in welcoming our host for today's session, SHP's Western Field Team Director, Keith Byerly.
Thanks, Amanda, and welcome everyone. Thanks for taking a little bit of time out of your day to join us today, and let's jump right into this. So I thought maybe we would start today with a trip in the Wayback Machine. And just as an illustration and a reminder that whenever we talk about yield data or yield monitor systems or even our combines in general, bad things can happen to our yield data. If I take a trip back in time to 2011, I am reminded of the launch of the Case Pro 700 monitor. And one of the new unique things about the Pro 700 was it was the changeover from the small compact flash cards to USB drives. Much more available, much cheaper, easier to read. Life should be good and simple, right? Problem was life didn't prove to be as simple as we had hoped. We, as a commercial retail agronomy operation and a precision ag department in my prior life, we did what we always did. We got growers' monitors ready. We helped them get prepared, made sure they had the right data on their cards. Monitors had planting maps on them and things like that, and sent growers out to the fields. And as it would happen, 2011 harvest was the beginning of the 2012 drought. And there was no rainy days that stopped us and gave us an opportunity to jump in there and read those cards and make sure monitors were performing properly. So as it happened, most everyone completed soybean harvest before we did any quality checks on these systems. And what we soon realized is that we had thousands of acres harvested and not thousands of acres of yield data coming off of these monitors, because those monitors required a very special USB drive that was supposed to ship with the Pro 700 and was usually tucked away safely underneath the seat with the manual that had never been opened and some other things. And long story short, we had all of those acres harvested and we never got that data back because CNH did a poor job of communicating to us the need for the very specific data card and USB. And that's just one story, not picking on Case, but definitely one of the most legendary ones that comes to mind when it comes to data failure in yield systems. So the reason we're here today is just that, to talk about yield monitor systems and data, which of course are critical to your operation and to furthering our mission at Soil Health Partnership, which is to promote the adoption of soil health practices for the economic and environmental benefits of our growers and their lands. For those of you who aren't familiar with Soil Health Partnership, we are a farmer-led, farmer-focused initiative of the National Corn Growers Association, focusing on soil health and the implementation of conservation practices, and the work that it takes to help growers implement those practices on their farms. Again, I'm Keith Byerly, and I serve as our field manager for Kansas and Nebraska. I come to Soil Health Partnership with 20 plus years working in the ag retail world, and almost all of them specifically in the precision ag sector, managing and working in precision ag hardware and data. So as we think about where we're at in the cycle of our growing season and already into it, what do all of these things have in common? We've got our tractor, combine, augers, all of this stuff. Well, whether it's servicing the tractor, servicing the combine, changing the fluids in those things, setting augers, reflighting grain carts, making seed decisions for 2021, there are hundreds of jobs that a grower has going into harvest, all of which have to be done before a combine ever turns a wheel. And to that end, we don't ever want to forget the dozens of grease zerks, all of the fluids that need changed, the outside filters, the inside cabin filters, and all of the wear parts that are part of a combine. We also need to remember that when it comes to data collection and documentation, that Harvest of 2020 is a once in a lifetime event. We will never see the same set of weather conditions, the same rainfall, the same hybrids, and all of these things culminating together to give us the yield results that we're going to see this year from our farms. And when it comes to recording that, there are all of these pieces on a yield monitor system that need to be inspected and maintained, just like, or in addition to all of those pieces that the combine already has that have to be inspected and maintained. So as we think about those, we really want to focus in today on 4 important considerations for the collection of harvest data. And we're going to start off our conversation today talking about yield monitor basic components, the wearable and non-wearable parts that need to be checked, how those parts work, and some of what can fail before and after we go out to the field. We're also going to talk about basic steps to set up and calibrate your yield monitor system, what you can ensure and what you can do to make sure you get the best accuracy possible from your system. Knowing your data flow, know who your data is going to, know how it's leaving the field, and when it's doing those things and how that data is moving around your operation. And then finally, special considerations for this cropping year. What has happened in 2020 that makes it substantially different from other years from a harvest system standpoint? So as we transition here to talk about the components of a yield monitor system, I intentionally have an old TR98 combine up in here because for the last 22 to 25 years, although the combines have changed pretty substantially, where components are and what components are on these yield monitor systems hasn't dramatically changed. The heart of any yield monitor system starts with our grain flow sensor at the top of the clean grain elevator. We have a moisture sensor that reads the grain moisture every few seconds. We have to have a clean grain elevator speed to tell us if the combine is running. We have a GPS antenna for mapping location and hopefully or possibly speed input. We have that yield monitor head unit in the cab that records the data. We have a header position sensor that tells us when the yield monitor is recording or when the yield monitor is supposed to record. And we have, again, that ground speed or travel speed sensor, because we have to remember at all times, whether it's radar, wheel, or transmission, speed times swath times time equals our area covered. That's the only way that we get area, and it's that same formula whether we're using GPS or not on our yield monitor system. So as we move into that first component, we need to remember that yield monitors or yield sensors come in different shapes and sizes. Some books will call them flow sensors, other ones call them yield sensors, but however they are or however they're named, they work in pretty much the same method. You've got the clean grain coming up the elevator, carried by the paddles. At the top of the elevator, it throws that grain into the flow sensor. That flow sensor works as a scale, and it measures that by measuring the pressure against the bar and sends that signal off to the monitor unit to record what's going on there. So there's 2 things that we immediately want to check when we think about checking our flow sensor pre-season. And remember that when we go to check our flow sensor system, most of them can be checked simply by lowering the bubble up auger. We don't necessarily have to loosen bolts. We don't have to take things apart to get in there and check where things are at. We may have to take it off to service it, but not necessarily to check it. But when we get in there, we're looking at this pad itself to see what wear looks like on that. And we're inspecting the load cell down below. So when it comes to the pad, most systems have a pad that's covered in a high density plastic. There's a metal plate underneath here, And this plastic is designed to wear out every 3,000 to 5,000 acres. As it begins to wear, you'll see cupping develop, especially here on the curve area on systems that have a curve, or it will just wear somewhat evenly and begin to expose the head of these bolts that hold that system onto the impact plate. That's the wear part of it. The other part is rodents will sometimes get in here and work on this high density foam or the plastic that protects some of the sensitive electronic components back in here. So those are the two pieces to check when it comes to the flow sensor itself. We also want to make sure that when we are looking at these to go take them off for any service, we know what bolts to remove. This is, again, this is a load cell, just like a scale on a grain cart, and these bolts that hold it to this housing are torqued to a specific specification, and that is calibrated for the torque setting of those bolts. If this bolt or these bolts are removed accidentally, this system is no longer at its specification and may not be able to be calibrated properly afterwards. Once you assure that all these parts are in proper working order, it's important to understand that when you're out in the field, one of the big problems that we can see, especially with New Holland combines, is that in wet conditions or when we're harvesting down crops, we will see a buildup of dirt, mud, debris on these plates. And over time, you may notice that your yield isn't moving around like it should be. And that can be a prime culprit for that, is because of buildup of dirt or residue on this impact plate. While the elevator chain itself is not a specific component of a yield monitor system, it is certainly, without a doubt, essential in making sure that a yield monitor functions properly. Understanding that most yield monitor systems have a flow sensor at the top of the clean grain elevator, we have to be considerate of the fact that as we adjust tension on our yield chain, or as we adjust tension on our elevator chain, the tension on that can directly impact the flow of our yield monitor system and thereby calibration. That's why you'll see many systems, if they're installed aftermarket, have a lower bearing adjuster on them. Even factory ones from John Deere will have a lower adjuster bearing to use when a yield monitor is present, because there is a specification here at the top of the clean grain elevator, whether you've got a deflector or whether it is a clean elevator there at the top. There is a specification for clearance there, and if you adjust that too tight or have it too far, grain won't come around that corner properly and hit our yield sensor in the way that we want to have it happen. Also have to consider this if you decide to replace that elevator chain with something like a precision planting one, where it has cupped paddles that direct the grain differently. Anytime you replace that chain or replace missing paddles off of your chain, after a calibration is done, remember that it can change the amount of grain flowing per pulse to that flow sensor. And thereby, in those situations where you replace the chain or replace paddles, you may need to recalibrate the system to ensure accuracy of yield collected after that job is done. Next up, we're going to transition over into the moisture sensor. And the moisture sensor system on yield monitors is legitimately one of the most part-intensive systems that we have out there. Regardless of where they're at, whether they're on the side of the clean grain elevator or in the tank, they all work in the same way. They rely on grain coming in from the grain elevator system to fill a sump and have grain sit there for a few seconds to be measured. And as we elaborate on that a little bit more, let's talk about the pieces that can fail when it comes to a moisture sensor. So within this moisture sensor system, we typically are going to have the moisture sensor itself, which is a block with a fin on the back side of it, that fin being the moisture sensor. Embedded in that block will usually be some sort of a temperature sensor that looks like nothing more than a small pin the size of a pencil eraser. Beyond that, you'll have a photocell very similar to what is on a yard light that is inside of this moisture sensor, looking at grain and deciding when to send a signal to a control circuit that reads this photocell and sends 12 volts out to the motor. And this would be the case in a John Deere, this would be the case in most others, where that motor augers the grain away. So as grain goes up the clean grain elevator, it falls in here. As it builds up over a few seconds, it covers this moisture and temperature sensor to get a reading. Once it builds to a certain level, that photocell or eye sends a signal to the auger motor to auger that grain back into the return side of the clean grain elevator, or in the case of some of the Deere combines, directly into the grain tank. So pre-season, you always want to make sure that you take this apart, you take this auger out and make sure that it's clean of last year's grain. And it turns that this auger will come out and that you can move things when it's apart. You can remove the moisture sensor block on most of these systems, and using your hand, reach into there. This is nowhere near any moving parts when the combine's off, but reach into there, cover that photo eye, and you'll hear the click. You'll hear this motor engage and move grain away as long as there's 12 volts to the system. When you're out in the field, if you're not seeing your moisture move around on the monitor a few tenths of a point every 15 to 30 seconds as you go through the field, it's likely because this motor isn't cycling grain properly through the system. This usually happens because a fuse has blown to the system, which is common when we start getting nights with freezing temperatures and we're harvesting grains that are above market weight. When you have grain of 18 or corn of 18 and above, just that freeze at night from temperatures being in the 20s will create enough tension in here that if it goes to move the next morning, it may pop that fuse. It can also happen again if you're doing down crops where you're getting a lot of dirt into the system. So while there are a lot of moving parts, it usually comes down to the photocell or the control circuit isn't getting a signal through, isn't getting 12 volts to that motor to tell it to clear out. And you can usually find these problems in just a few minutes with nothing more than a test light or a multi-tester to see where you do and don't have voltage as the system works. The next component in making sure that the yield monitor system is working properly is the header height sensor. And header height sensors are simply a potentiometer, and they are located somewhere on the feeder house and are integrated into most machines in this day and age. However, you will still see a lot of them on that feeder house that are the early traditional bar and arm system, mounted out with a spring or a chain to that feeder house, mechanically going up and down. One of the things that is most likely to fail on these systems is that you may have a piece of debris or residue, a corn stalk, a sunflower stalk, something like that, physically entangle into this mechanism and keep things from cycling properly. If all of a sudden you're out in the field and the header height status, that monitor quits logging on and off, it's usually related to something happening from a residue standpoint. Some case combines have a header height sensor on each side of the feeder house, but a general rule of thumb on all systems, it's the one that is on the ladder side of the combine that is used for the yield monitor system. All of these systems have a calibration process somewhere within their monitor systems that you can set where that on and off point is for the feeder house, and you'll want to do that for each crop differently as you have different heads on there. And as you get into that calibration screen, you will be able to see the counts usually on that sensor to verify that it works properly as you cycle it up and down. Next up, again, is a piece that isn't necessarily a part of the yield monitor system per se in ensuring that it can calculate yield, but it is certainly a part that makes it work or not work, and that is the elevator speed sensor. Aftermarket yield monitor systems don't come with their own elevator speed sensor. They always tie into, or as far as I know, always tie into the system that is already on the combine. Generally speaking, elevator speed sensors either work or they don't. Almost never see a partial failure of an elevator speed sensor. And they're very simple in operation. They're mounted on the left side of the combine on the cross auger, and they measure RPMs. And since they tie into the factory elevator speed sensor, your combine is going to display elevator speed on its screen, or on older combines will have a low elevator speed warning on the post or somewhere in the cab that beeps or lights up if that elevator speed is below the number they expect. So if one fails, they will both fail. You won't have elevator speed showing up on one monitor and not the other. And very simple to replace. Always check the ground if they do suddenly fail on you. A lot of times it's not the sensor itself, but it's how it's grounded to the chassis. Next up is speed of the combine. And speed of the combine, again, controls yield because it determines the area that's logged per second. Speed can come from three possible sources. It can come from wheel speed, which is usually acquired from the top of the transmission, or in some cases, in early New Hollands and Gleaners, you may have actually mounted up a sensor on the axle shaft itself to count revolutions there. It is more often determined from the GPS position on the system. And in some rare cases, you may have a radar system on that combine that reads speed. Much more common on tractors or sprayers than it is on combines, though. I would say from my preference that GPS is the preferred method of speed, especially if you are running a GPS level better than WAS or Starfire 1, because wheel speed can be affected by wheel slip, and radar can be affected by wind and residue blowing around the field. Always remember that the speed source for your combine and the speed source for your yield monitor may not match up, especially if you have an aftermarket system in your combine. It is not uncommon, and it is certainly not a worry, to see your combine speed and your monitor speed, your harvest speed, be off by 1 or 2 tenths of a mile an hour while you're at harvest speed, or 2 to 3 mile per hour at road speed. Those small differences are going to have a very minimal effect on your yield quality for the year, the quality of that yield data you require, and don't need to be recalibrated. But if you see a variation bigger than that, it certainly is worth going through the process of recalibrating your ground or radar speed system. GPS systems cannot be calibrated for ground speed. Of course, while we're on the topic of GPS, it would be remiss to not talk about the GPS antenna itself. And as a good rule of thumb, it's probably safe to say that GPS problems are never going to show up in the field, or never going to show up in the yard or at the edge of the field before you start a field. They always happen while you're out in the field. All monitors are going to have some sort of a way of warning you when your GPS signal is degraded or lost. And in either one of those cases, it can, if your GPS is completely lost, you will not be creating a yield map. If your GPS is degraded, you may not be creating a yield map. So If you lose your GPS while you're opening a field, I can't say this enough. Get out and look at your GPS antenna. I can honestly say over the last 20 years, I've been on well over a dozen service calls where the grower lost GPS, the monitor was showing no GPS, and get to the field and find a tree branch in the grain tank or a tree branch on the roof of the combine, and the GPS antenna has been knocked off of the combine while they were opening a field. And it happens a lot on these systems because the GPS is usually the highest point on that combine. Another consideration when it comes to GPS is thinking about if you do lose it on a regular basis, when is it being lost? If you're losing it several times a day, start to pay attention to when it happens. Does it happen when you're traveling down a hill? Does it always happen when the tank is full and you're waiting for the grain cart? In both cases, bin extensions can certainly be a culprit on these things. If I've got that GPS antenna mounted here on a New Holland in its factory location at the front of the bin extension, if I get that bin extension full enough, or if I get my bin full enough, I can partially or completely cover my GPS antenna with grain, and at that point in time, I'll lose signal. If I have a system here on a paradigm, when my bin extensions were up, it was not uncommon going downhill for the bin extensions to hide the GPS from seeing part of the sky and losing GPS in that regard. And so start paying attention to those things, and a lot of times you'll figure out what it is. And of course, if you're using a business band or CB radio, think about the distance from the GPS antenna to that radio antenna and make sure they're not mounted on the same piece of metal there on top of the cab, because with modern cabs being so much plastic, you find one place to mount something, you often use it for several things, or that even the cable for the two isn't coming through a bulkhead connector somewhere into that cab in the same place. It's very common that growers will discover that they lose GPS when somebody keys the mic, and normally just moving a cable or moving an antenna will solve that problem. Next up, I'm going to talk a little bit about power cables, and power cables should not be overlooked, especially early in the season. If you have an aftermarket yield monitor system like an ag leader or a precision planting system, a lot of times they're going to get power directly from the battery for at least the moisture sensor, if not the moisture sensor and the monitor. If that's the case, make sure that if your cables are directly at the battery, your power cables are there directly at the battery, inspect them pre-season to make sure that they're not covered in corrosion, they're not melting away from the elements and things like that, and that they are in good contact with the terminals on your battery. Also remember to disconnect those battery cables whenever you're doing major service on the combine. If there's welding to be done, especially if there's welding to be done, make sure you're disconnecting those battery cables, and it's always a good idea to unplug the cable out of the back of the monitor before you do that. And first thing in the season, or something gets left on overnight, don't forget that it's also a good idea to make sure that monitor is powered off before you put jumper cables or a battery charger on there to jump start that combine. And if you disconnect the battery at night, if you throw that main battery disconnect switch, make sure that your yield monitor system has completed its shutdown procedure before somebody flips that switch. A lot of these systems will have a clean out process on the side mount or on the moisture sensor that takes 15 to 20 seconds after the monitor goes out. Your monitor will stay on a backlit moment until that process is done. If that backlight's on, it can still be storing data to the monitor. So again, just make sure that shutdown procedure is complete before you throw that main battery disconnect at night. As kind of the final pieces of the yield monitor system, we want to talk about the monitor itself. And I think a lot of folks forget that we need to do maintenance on the monitor as well. Many of our monitors require a data card to log yield. And this data card will store the summary data for the yield as well. Or while that card stores the spatial data, our monitors store summary data for yield. If your monitor is, if the combine has a dead battery or that main power is disconnected all summer long, your monitor may start up in the wrong year, which means that while you have a clean card, it's putting summary data on top of summary data and making data retrieval clunky afterwards. So always make sure that you've cleaned the previous season off of your monitor. Make sure that you have proper time and date set on that monitor, including, I know it seems somewhat odd to say it, but proper year. And make sure that you've got the grower farm field structure in that monitor matching the grower farm field structure that you have on the planter. It makes moving planter maps much less confusing, and it makes putting that data together after harvest much easier. And of course, as we roll that combine out of the shed, we want to do a few more checks on the screen itself to verify some things like GPS and whatnot. Even every display is going to have some way of telling you if it has GPS, differential corrections like Starfire 2, OmniStar, RTK, etc. Even old monitors like PF3000s and YM2000s. There's going to be, in that case, a D or a G there on the screen. John Deere will have a 3D RTK. We'll have a happy satellite with GPS that doesn't have any yellow or red warnings on a case system. AGCO systems have our kind of traditional signal bars there. They're all there. The same is true for things like the logging, area off, recording, the green arrow down. These systems will tell you as you put that head up and down whether that logging sensor is working properly and things like that. And if you don't know what those things look like for your monitor, don't be afraid to go to YouTube or to Google and bring them up. There are lots of great resources out there that will help you through kind of that startup procedure with your monitor. If you've changed monitors, if you just don't remember, those things are out there to walk you through in 3 minutes, the basics of what you need there. And some monitors, just as a reminder, will require flow on the sensor before the logging starts. So just because you put the head down in the yard and that doesn't switch, that doesn't mean that the header height is failing. It may need to have yield and elevator speed before it will do it. Again, know your system, know what it requires from you. As we start to change here now and wrap up that conversation about the parts and the maintenance on the monitor, I want to start thinking about the calibration itself of the monitor. And when it's time to go to the field, we need to make sure that we have the data logging system right and ready. Know if you need a card on that monitor to log or just to download. Case New Holland monitors, Ag Leader YM2000 through Insight, Brown Box and Green Star 2s, most of AGCO monitors, and a lot more always require a card in them to log yield data. Newer monitors like Green Star 3s and 4s, Ag Leader, Integras, and InCommands, 2020 system from Precision Planting, they have large amounts of internal memory in their monitors, and they only need a card when you go to the download procedure. Again, know your process for what you do, and know that you've got that right manufacturer recommended card, like we started our story off today with the Pro 700s needing their little rubberized Envoy data cards. Good rule of thumb is SanDisks are manufacturer recommended cards in most ones, but if you've got some sort of a generic label on it, that's no good. And if you do have to have a card in your monitor to log data in it, I encourage you to do something large and noticeable to your card so that when it leaves the combine, everyone knows that it's yours. Attach a cow ear tag to it, paint it orange, find something that you can do to your card so nobody loses it and it's easy to find at all times. When it comes to calibrating your monitor, there is no substitute for knowledge. If you don't know the procedure for doing calibrations on your monitor, look it up and don't always assume that it's the same that it has always been. Different monitors require different calibrations. A lot of our newer monitors have a calibration wizard built into them. They will tell you exactly how to do calibration if you just hit the button to weigh a calibration load. Know whether your monitor needs to be calibrated first or at any point in time during the growing season, and those calibration loads can be applied backwards. And know if you need one calibration load or multiple calibration loads to get the best accuracy out of your monitor. In this case, we've got what is our single point calibration. Here's a multi-point calibration. And again, I could easily do 4 more hours on all of the different nuances of calibrations and things like that. It's important to know that calibration processes do change with time. They change with software. And what used to be a system like this in John Deere for years and years and years is now a process that looks like this in our Green Star 3s and Green Star 4 monitors. They evolved to get the best accuracy and be more user-friendly as time goes on. Older displays like Green Star 1 and 2s may require a recalibration of moisture may require a recalibration in season as conditions change as well. We need to think about the differences in volume through our combine between corn and beans. Corn and soybeans require different calibrations, not only because the density of that crop is different, but mainly because of the flow. If I have a 40-foot swath of soybeans that are doing 70 bushel an acre going through my combine, I still have less than half of the flow going through my combine that I do if I have 220 bushel an acre of corn going through with an 8-row head at exactly the same speed on that combine. And it's because of that differences in flow. When I'm doing corn, a lot of my calibration points are here on the high side versus beans here on the low side. Why I have different calibrations for different crops. And that's why some monitors are going to ask you to do different calibrations if you're harvesting different conditions. If I'm doing 160 bushel dry land and I've got a lot of flow down here, I'm combining one direction on down crops, things like that, I may need a calibration here versus 280 bushel corn on my bottom ground, completely different scenario. And again, know what your monitor wants. Knowledge is power when it comes to properly calibrating your system. Some yield monitor systems want small loads of 3,000 to 5,000 pounds at a time to ensure the best accuracy. Other systems want an entire truckload, 40 to 60,000 pounds weighed as a calibration load going through that system. If you're doing small loads, please make sure that you use one cart and one moisture sensor. Don't transport it from the combine to the weigh wagon to the weigh cart, or I'm sorry, combine to the grain cart to the weigh wagon. Go straight from the combine into the weigh wagon. If you're using a grain cart with a scale, that's fine. Just make sure that you park it on level ground and don't move, and make sure that your scale on your grain cart is accurate. It happened to me just the other night. We calibrated our yield monitor system. We got down to 0.2% accuracy, and everything looked good until the field all went to the elevator, and we were off 1,000 bushel on 24,000 bushel, because we then remembered that grain cart scale is off by about 4% that we discovered last year, and our calibration is accurate but wrong. So remember that, and remember when it comes to doing your moisture calibration, that a handheld moisture sensor is fine. It will get you close, but if you want to have a very accurate system, the more accurate, the better on moisture sensors. And taking a sample to the elevator is probably the preferred method to get moisture. Successful calibration, again, is different for every system. You're going to drive yourself crazy trying to get a perfect calibration. So know what a realistic target is. Some systems that are single point calibration are recommended in the manual, that if you can get that to plus or minus 3 to 5%, that is an accurate calibration. Other systems that have multi-point calibrations are going to say in the book that anything less than 3 is an acceptable calibration. So know what that number is, and know what you have there. If you're doing research on the farm, such as working with us here at Soil Health Partnership, please take the time to do the most thorough calibration process possible for better results. If you have to repair a yield grain handling system like an elevator chain or a flow sensor or an impact plate in season, know what process you need to do there as well. Some monitors will let you freeze your calibration up to that date and time and recalibrate from there forward. Others are going to require you to create a new crop type like corn 2 or soybean 2 to keep those things separate. Transitioning away from the calibration side here, again, know your data flow and know how your monitor removes data. An Ag Leader, Insight, Integra, or Versa, for instance, is going to erase the data 30 days after download from that monitor system. While monitors with a card in them while they're logging don't necessarily have an internal backup. So if I have a monitor like a Pro 700 and somebody takes that card and leaves the field and loses it, I've lost my yield copy for the entire system. There's no way to get that out of the monitor and create maps. So if someone downloads your data before harvest is complete, ask them to explain to you how your monitor handles the data download. Again, Ag Leader, Insight, Integra, Versa, tell them to leave a copy on a USB with you if they take data and leave your field. Case New Holland, when they copy that data on your card, make sure when that card goes back into your monitor that you can see your maps on the display after that data is downloaded and the power is cycled to that monitor. If I can see my map on the monitor, I know that my data is safely still there on the card. And with Green Star 3 and 4, Ag Leader in Command, you don't have to worry about it. A backup of your data is safely there on your monitor to be downloaded again at another time. Best practice is to always know who downloads your data in case something comes up missing. When it comes to cloud services, these things can be incredibly confusing, so make sure that you understand them. Check annually to see if the connections that you have made are still the ones you want. If your salesman has left the co-op, or if you've changed retail suppliers of who you work with, you may not still want to be sending those folks the data that you had before. So delete those connections that are no longer needed. And I can assure you that your trusted advisor or your partners that you work with want no more than what they need. If I'm doing research on one field with you, I don't want to see all of your farm's data. I don't want 3,000 acres of yield data of yours to keep safe from the world if I only need 100 acres of it. So make sure that these data sharing connections are set to do only what you want to do. And always consider the cost of these free services. If somebody is giving you free maps or free software because you upload data to them, what are they getting in return? Know the data privacy policies of anybody that you're sharing your data with. If they can't assure you that your data is secure and it's not shared with other entities or sold, ask yourself what it would cost them to rent the ground, plant a crop, grow it, harvest it, and do all of that work. That's what your data is worth to them, and that's the cost of those free services. So I'm not against those things, but just make sure that you understand the data proposition and that you know what your data is worth if they can't provide and prove to you security and privacy with your data. Finally, just a few special considerations for the fall of 2020 harvest. Last year's calibrations may not match this year's crop. If you had that monitor calibrated down to 0.1% last year, but you have low flow scenarios like the derecho or some drought this year, that difference in test weight, that difference in flow through your combine may not mean that it is proper. You can have the same yield of crop out there with very different flow conditions, or the same volume of crop with different test weight, that drastically changes the accuracy of your monitor. Also remember, new combines are not always ready to go. Initial calibrations can easily be 40 or 50% off when you do that first load. And be wary of those repairs that can knock you out. Any repair or new hardware like a new head that changes the volume or efficiency of the combine, like a new bubble up auger, or not a new bubble up auger, a new cross auger, or a new flighting in the corn head, things like that, can change how fast crops move through your crops and mean that your combine isn't accurate when you go out to the field to start that first load of the year. This exact data about what happens to your fields and this year's set of weather conditions, again, will never be available again. So do the best you can the first time out. I'm a 4-H shooting sports instructor. The first question we always ask kids as we start the shooting sports year off is, what is the safety? And if they've had hunter's ed, they usually reply that it's a mechanical device that can and will fail. Yield monitor systems are mechanical and electronic devices, and they can and they will fail, and usually at the most inopportune times. Murphy's Law. Hopefully today, after this webinar, you feel more confident going into the field with your device, and you know that your device isn't already at or near a state of failure, and you feel a little bit more confident in spotting the warning signs that a failure may be coming or imminent. Thanks to the folks listed on the screen for their resources in yield monitor calibration and manuals that I used to put together the images for today's presentation. So back to you, Amanda.
Excellent. Thanks, Keith. And thank you all for attending today's Soil Sessions webinar.